Welcome to
Nay.
Do it.
Channel Everyone. Okay, wow, JJ Jiyoung, thank you for being here. Today we are diving into something that feels incredibly intuitive but is apparently a massive mystery in cognitive science. How do we build things?
Not just build things, Isabel. How we plan to build things step by step in the physical world when our brain is on a budget. Like trying to assemble IKEA furniture when you're tired and just want it to be done.
That is a perfect everyday analogy, Jiyoung. The research we're discussing asks, what happens in our minds when we do that? When we look at a pile of blocks and think, how far can I make this tower reach out before it falls over?
Right, the overhang tower task. So the big question was, do we have a perfect little physics simulator in our heads running full calculations? Or do we just use quick visual shortcuts? And separately, do we plan many steps ahead or just one at a time?
Precisely. These have been two separate debates: the physics debate, simulation engine versus heuristic; the planning debate, deep look-ahead versus myopic next step only. This study asked a brilliant, unified question. What if we use both asterisk and switch between them based on how much mental energy, or time, we have?
It's a resource-rational approach. Your brain isn't stubbornly using one expensive tool for every job. It has a toolbox. When the task is simple and you have time, you might use the precise, slow tool, the internal physics simulator. You mentally test different block placements.
The intuitive physics engine, IPE for short.
Yes, but as the tower gets more complex or you're put under time pressure, that simulation gets too costly. So your brain switches tactics. It starts using faster, rougher tools, like visual heuristics. Maybe it just looks at the overall shape, compares angles, uses rules of thumb.
And here is the fascinating dual transition they found. It's not just the asterisk prediction asterisk mechanism that changes. The asterisk planning strategy changes in parallel. With less cognitive budget, you not only switch from simulation to heuristic, you also switch from deep, multi-step planning to shallow, just the next block planning.
So a double shift. Under pressure, your brain goes, okay, forget simulating the physics perfectly for 10 steps ahead. Let's just look at this, guess if it's roughly stable, and only worry about the very next piece. It's adapting on two levels at once.
Exactly, this is what was missing from the old debates. They were looking for the asterisk single mechanism. But the brain is more pragmatic, more hierarchical. It has a repertoire of strategies and it dynamically reconfigures them, trading computational cost for accuracy based on the situation.
It unifies those long-standing debates. We are not asterisk either simulators asterisk or heuristic users. We are not asterisk either deep planners or myopic agents. We are adaptive systems that use a mix, and the mix changes with our available resources.
That is, honestly, so comforting. It means that when I'm staring at a wobbly stack of books and can't figure out how to add one more, it's not that I'm bad at physics. My brain is just rationally allocating its limited power. It's a feature, not a bug.
A very optimistic way to look at it, Isabel, but yes, it shows a flexible, efficient cognitive architecture. The study uses this overhang tower game to reveal that hierarchy. Early, easy moves, full simulation, deep planning. Later, complex, pressured moves, fast heuristics, shallow planning.
It paints a picture of the mind as a remarkably resource-rational planner for the physical world. One that is built not for perfect optimality, but for robust, adaptive performance under constraints.
Which is basically the story of being human, isn't it? Thank you so much JJ and Jiyoung for breaking this down. It makes a complex paper feel, well, accessible.
My pleasure.
Thank you for having us.
And thank you Asterisk for watching. We'll see you next time.